Today we are tackling one of nature's most beautiful and, let's be honest, kind of magical sights. It just shows up in the sky, right? But the real story behind it is this incredible dance of physics happening all at once inside millions of tiny little raindrops.
You know the feeling. The rain stops, the sun comes out, and there it is, that perfect arc of color. We've all seen them, but have you ever really stopped and wondered, how? How in the world do you get that from just sunlight and water? Well, today, we're going to find out.
All right, so the very first clue to solving the rainbow mystery, well, it actually has nothing to do with the rain. To figure out a rainbow, we've got to start with the light itself. You see, the sunlight that hits your face, the stuff that looks kind of white or maybe a little yellow, it's not one color at all. No, it's actually a secret party of all the colors you see in a rainbow. Red, orange, yellow, you know the drill. They're all mashed together, traveling as one big beam of white light.
So how do we know this for sure? Easy. We use a prism. When that white light hits the glass, it slows down and it bends. This is called refraction. But here's the really cool part. Each color bends at a slightly different angle. Red bends the least, violet bends the most, and that forces them to split apart, revealing the whole hidden spectrum. The prism isn't creating the colors, it's just unlocking them.
So now let's get to the scene of the crime. Obviously, we don't have giant glass prisms just floating around in the sky, but after a storm, we do have billions and billions of tiny little spheres of water. So what if? What if every single raindrop is acting like its own tiny liquid prism?
And that key action, that word we just used, is refraction. That's the sciencey term for it. All it means is that light bends. And it happens anytime light goes from one thing, like the air, into a different thing, like water. That change in substance makes the light change its speed, which forces it to change direction, to bend.
And when you think about it, the comparison is perfect. A glass prism, it's transparent. So is a raindrop. A prism bends or refracts light. So does a raindrop. And, most importantly, a prism separates white light into a rainbow. And guess what? So does a raindrop. They're doing the exact same job.
Okay, we've got our light source, the sun. And we've got our tiny prism, the raindrop. So let's put it all together. We're going to follow one single ray of sunlight on its secret little journey through one single raindrop to see exactly how this magic happens, step by step.
Okay, step 1. Sunlight hits the outside of the raindrop. The second it passes from the air into the water, it slows down and bends. This is that first refraction we talked about. And right at this moment, the colors are already starting to split apart, just a little.
Now for step 2. This is cool. The light doesn't just pass straight through. Instead, when it hits the back wall of the raindrop, it bounces. It reflects off the inside surface like a mirror. This is called total internal reflection, and it's so important because it's what shoots the light back in our direction, towards our eyes. And finally, step 3. As that light beam is leaving the raindrop, going from water back into the air, it speeds up and bends one more time. And this second bend is like an amplifier for the color separation. It fans those colors out even more, making them nice and clear and visible to us. So there you have it, the 3 essential ingredients in the recipe for a rainbow. You need sunlight, that's your light source. You need raindrops, those are your tiny prisms. And, this is the most important part, you need you, the observer, standing in just the right spot at just the right time. Okay, so we've cracked the code on the colors, but that leaves one last big question. What's the deal with the shape? Why is a rainbow always that perfect classic arc? I mean, think about it. If this whole bend, bounce, bend thing is happening in millions of raindrops all at once, shouldn't the sky just be, I don't know, a giant blurry wash of color? Why do we get that clean, organized arc every single time? Well, the answer comes down to one thing: geometry. It is all about the angle. The laws of physics are super specific here. That light is always going to exit the raindrop at a very precise, very predictable angle. And for red light, that magic number is 42 degrees. It's not a suggestion, it's a rule. For you to be able to see the red light coming out of a raindrop, that drop has to be positioned at a perfect 42-degree angle from your line of sight. The other colors, they come out at slightly different angles, which is why they form those neat bands right below the red. And here's the part that just blows my mind. You're not seeing a full rainbow from one raindrop. You're seeing one color from millions of different raindrops, all at the same time.
You only see the red light from all the drops that are at that perfect 42-degree angle for you. So get this. That collection of raindrops, all at that perfect angle, actually forms a full circle in the sky. A complete circle. The reason we only see an arc is because the ground gets in the way. The Earth cuts off the bottom half. If you were in an airplane, you could actually look down and see the entire 360-degree rainbow circle. How cool is that?
I think this quote just says it all, doesn't it? It's beautiful, sure, but it's also this amazing, large-scale physics lesson playing out right in front of us. It's a reminder that science and beauty aren't separate things. They're woven together.
So that kind of leaves us with a final thought, right? If one simple, tiny, humble little raindrop is capable of all of this, of bending and bouncing light to paint a perfect 42-degree circle across the sky, what other incredible wonders are out there, just hiding in plain sight, waiting for us to get curious?